Let us see now few more reactions of acetylene. One of the most important reactions of acetylene is the hydration, addition of water to the triple bond. The addition of water to the triple bond, usually in the case of olefins, is done by means of water and acid, HF plus and H2O. But in this case, this is being catalyzed by the mercuric ions. It is treated with mercuric sulfate and sulfuric acid, fairly strong sulfuric acid, 50% sulfuric acid. When acetylene reacts with this reagent, mercuric sulfate and then sulfuric acid, this gives rise to acetaldehyde. This is just nothing but a Marconic of addition of water to the triple bond. The Marconic of addition of water to the triple bond gives rise to, as we just see this here, we can have CH2OH will be produced, OH will be added to this, and then this CH2 will be added, giving rise to a double bond. That is CH2 double bond CH2OH. Actually, in other words, this is an enol. This a vinyl alcohol CH2 double bond CHOH. So when this gives rise to an enol, this enol is just nothing but vinyl alcohol. This vinyl alcohol immediately tautomerizes to give rise to a more stable acetaldehyde, which is the keto form. So this is the only aldehyde produced from an alkyne. All the other alkynes, the internal alkynes will not produce an aldehyde, it will produce only ketones. So acetaldehyde is produced by the hydration of acetylene by means of mercuric sulfate and sulfuric acid. So the product obtained on the treatment of acetylene with mercuric sulfate and sulfuric acid is acetaldehyde, which is obtained by the tautomeric conversion of the vinyl alcohol to give rise to acetaldehyde. Other internal alkynes, the acetylenic compounds having the acetylenic groups internally, that will also react with mercuric sulfate and sulfuric acid, but will give rise to ketones. Here also the same thing happens. H gets attached to one carbon atom, OH gets attached to the other carbon atom, an enol will produce, and the enol will change over to tautomerize to give rise to a more stable keto form. So you will get methyl ethyl ketone or 2-butanone will be obtained in this case. And we have an unsymmetrical type of an acetylene. As for example, we have a phenyl group on one side and methyl group on the other side. When it undergoes this, wherever a carbonyl group is, more stable carbocation will be formed here. Therefore, OH will get attached here and H will get attached here, again undergoes tautomerization, so that you have phenyl ethyl ketone is obtained as a product. In all these cases, the reaction is being catalyzed by means of the mercuric salt, mercuric sulfate in the presence of sulfuric acid. It is also a hydration. It is just nothing but just like hydroboration or oxymercuration. This is also a hydration reaction, but only thing is the species, the substrate undergoing hydration is not a olefin, is an acetylene. And these are all some few important reactions of acetylene. Now let us go to a last bit, which is actually a diene. A diene is a species which contains two double bonds, and this is also not only this contains two double bonds, the two double bonds are present in conjugation. So this is known as butadiene or 1,3-butadiene. The double bond is here in this one carbon atom and 3 carbon atoms. This is the conjugated diene containing 4 carbon atoms. Therefore, this is a conjugated diene or 1,3-butadiene. When this 1,3-butadiene, some compounds are, some groups are added. As for example, when it is hydrogenated or when a halogen is added or when an HBr is added. As for example, in this particular case, the example that is illustrated, it is an example of addition of HBr to this conjugated diene. Normally, we expect the addendum, that is the group that is added to one of the double bonds, either this double bond or both the double bonds or one of the double bonds preferentially, depending upon the site of activity of reactivity. Depending upon the active nature of the group that is present in that. But in this case, we find that it undergoes what is known as an 1,4 addition. What is meant by 1,4 addition? One group adds to one carbon atom and the other group adds to the 4th carbon atom. Therefore, this is not an 1,2 addition, this is an 1,4 addition. Actually, when we add HBr to this, bromine adds on to this, H adds on to this. So, the CH2 becomes CH3 and then the bromine adds on to the other carbon atom. The most interesting thing is the double bond gets shifted between the second and third carbon atom. The double bond is between 1 and 2 and 3 and 4, but now in the product the double bond is between 2 and 3 carbon atoms. So, this type of addition is referred as 1,4 addition or conjugate addition.